Okay, give you a little bit of context here. Um, these are all of these hormones you're going to want to know the function of, okay? And that's why I think they're probably all listed on this table. If not, that's where your textbook is a vital tool then as well, okay? So with that, talking about this one, okay, we're going to start with that one. Why is that? Of course, it does have its function, cortisol, but what did we say in class that can be a problem with cortisol? Yeah, more is sometimes not better, okay? Because a shortened name, like for instance, somatotropin, we know is the growth hormone. Sometimes you say somatotropin, sometimes you just say GH. It's a growth hormone, okay? So you can take a shortcut with that one and say cortisol is a what type of hormone? It's a stress hormone, okay? So as we said, the best way to combat that is, just try to make someone laugh. And when that happens, they tend to feel a little better because it starts to release endorphins. Endorphins like dopamine, I think, is one. And maybe serotonin, I believe. That's somewhere in the brain then too. So here is your challenge, okay? Keep a straight face. Some of you probably can, okay? But with this, okay, that's hot. That's 360 degrees hot. Ha. Ha ha ha. 360 degrees. God, I don't know if I want to erase that. That's burning hot. 360 degrees is pretty hot. Yeah. Okay. All right. We'll go ahead and continue. Okay. So we've got, okay, anterior and posterior hormones, okay? What we want you to know, is it best that we go over these, or is that something you want to sort through yourself? Okay. So and to me, probably the best way to go through this is when we're talking about those that are anterior and posterior hormones, we're just looking at ones that are blue. Now I know there's a glare on there, so we're going to try to do our best. We've got aldosterone down here. Looks like that's epinephrine. That is probably glucagon. And then that's prolactin, thyroxine. And then looks like that's testosterone, I think. Yep. Because I understand there's a glare. Then insulin. Then I think you can see the rest of the way up there. Okay. So with that, if it has a blue star by it, prolactin, somatotropin, follicle stimulating hormone, thyroid stimulating hormone, you could say parathyroid or parathyroid stimulating hormone, okay? And then oxytocin. Of those, which one is on the the posterior side? It's oxytocin is on the posterior side. So does that go through the adrenal hypophysis of the pituitary gland or the neural hypophysis? You are right. Why are you right? Yeah, because there's also antidiuretic hormone, but notice that's not up here, okay? So with that, we'll just, let's see, what would be the best way to mark that? I'm looking for a color that we don't have up there, and I think I'll maybe try this one, okay? So therefore, I'm just going to put a mark up here. So this is NH for neurohypophysis, or just P for posterior, what makes the most sense to you? Okay, so we'll just put posterior pituitary. Okay, so PP, posterior pituitary for, oh, did you catch that? I didn't do that intentionally. I don't know what I was thinking. I wasn't. Okay, posterior pituitary for oxytocin, not cortisol. Okay, so therefore, eliminating the one that we knew was on the posterior side, what does that say about all of these other ones that have a blue star or X or whatever you want, asterisk next to them? It's on the anterior side. So anterior pituitary, and then so on and so forth, all the way down here to prolactin. Okay. All right. So that takes care of the blue one. All right. What about the one in the green? Okay. Therefore, what we would want to mark down is, are there more non-steroid hormones or more steroid hormones? There are more non-steroid hormones, so we're going to start with the steroid ones then. And all steroid hormones are composed of what? Cholesterol. Okay? So, if that is the case, give me a steroid hormone. Aldosterone, all the way down here in the bottom. Okay? I'm kind of running out of space, but I'll just move the camera over when we're done. So, SH, steroid hormone. What's another steroid hormone? Testosterone is one. What's another one? Estrogen. I think there's one more. That is correct. Cortisol is a steroid hormone. Okay? So now, all of them that have a green star next to them must be non-steroid hormones. Okay? So, as we go down the line, okay, calcitonin, I'm going to just put non-steroid hormone. Okay, insulin, non-steroid hormone. Okay, thyroxine, non-steroid hormone. And then, okay, then we've got glucagon, epinephrine, and aldosterone, of course, the steroid hormone. Okay, I think that's all of them. Okay. So now, I would find it very hard to believe, and you could, some of you are maybe doing this from memory because we're correlating it and we're understanding it, but I believe a lot of the information, again, is on this table. Okay, so as we go down the line, okay, sound is still good, we're still recording, all right. What is a hormone that's got this red star next to it? What does that possibly mean? It's an amino acid hormone, okay? So therefore, we've categorized all of these. Notice when we're talking about non-steroid hormones that are composed of amino acids, okay? In that case, it's just insulin and glucagon. Okay, we want to draw it that way. All right. So if it's got a brown star next to it, okay, then those are a polypeptide. So we're going to go ahead and go through which one of those are composed of polypeptides. And one way that you can do and think about this is if it is a polypeptide, why can't it have, for instance, oh yeah, I guess it could. These are steroid and non-steroid, sorry. Okay, I was thinking it was only the green ones. Okay, so what is a non-steroid hormone that is polypeptide based? One, it's a mineralocorticoid that has to deal with glucose metabolism. Insulin? No, because it's got that guy next to it. It's amino acid based, okay? So also deal with proteins, lipids, glucose metabolism. We said your energy is going to be very low, and it's a non-steroid, so it can't be cortisol. So it's going to be one, again, you're low on energy because this gland is just not secreting enough of it. What deals with glucose metabolism? Thyroxine does that, and that is a polypeptide hormone. Okay? So, as we, I got them backwards, don't I? Amino acid. Dang it, I got them wrong. Okay. Or else I could have left that up there. I mean, that was the whole idea behind this, was we want this one to actually have brown star, and then this one. Then we can do that. Okay, because you were right the first time. Insulin and glucagon are composed of that. Those are polypeptides. Okay. Then thyroxine is your amino acid based hormone. Okay. And it's not the only one. Okay. So we know thyroxine is one of them. Okay. What's another hormone that deals with glucose metabolism? It gives you a big kick in energy. It's adrenaline, but adrenaline is not up here, though. But epinephrine is. So therefore, we're going to do that. Okay. So those two are now linked. Okay. Okay. Now we're down to these last two boxes. Okay. Is anyone confused so far? It wasn't our intention to get them to flip-flopped. I just had it in my mind and I just glanced at this table. So that's why having this is really, really important. Questions? Okay. So what do we mean by a positive feedback mechanism? In class we said, what does that do to the change occurring in the body? It's usually associated with childbirth is one. So if we're talking about a positive feedback mechanism, why is that next to oxytocin? What does that do during childbirth, oxytocin? Whether it is a bovine, a swine, or us as humans, that oxytocin is going to do what to the female uterus? Yeah, it's going to cause those contractions to occur more and more forcefully. So therefore, oxytocin is a positive feedback mechanism. It's just going to keep contracting more forcefully until another hormone tells it to stop. It doesn't bring it back down to a normal level, it just stops it. But notice there's another one up there that also has a positive star next to it. And that is which hormone? Epinephrine. Because that's going to amplify a change occurring too. Because we know when that is secreted into the body, what is happening, what is going up. We said oxytocin is causing the contractions in the female swine, bovine, or human to contract more forcefully. And it just keeps doing that until another hormone says, okay, we're done. What is this epinephrine doing then? What is causing something to amplify inside the body? We said it gives you that kick. What's happening right in your thoracic cavity? Yeah, heart rate is certainly going to go up. So that's why this is a positive feedback mechanism too. Okay? So if that is the case, well then this color marker, we're trying to color code them the best that we can. Okay? What would be an example of, there's two of these now. Two of them. This is how we talked about them in class. And then we had that. Okay. These are examples of negative feedback mechanisms. In other words, when one hormone elevates inside the body, there's another one that counteracts that to cause it to come back down. Can you remember what two it was that we talked about? Glucagon is one, and insulin is the other. Okay? So therefore, I'm going to put this color all the way out here. Okay? I'll make it a little bigger. I don't know if you can see that on there. And then we said insulin. Okay, so these two counteract one another, insulin and glucagon. What are two more hormones that counteract one another that you see up here? It's a mineralocorticoid, because these two are glucocorticoids because it deals with glucose metabolism. The other set deals with a mineral inside the body. Calcitonin and parathyroid hormone. Okay? So we're going to put a big star here and then right here. So these two also counteract one another. So we can we'll maybe link those together. So these two counteract one another, and then these two counteract one another. So this is negative feedback, and then all the way up here with oxytocin and epinephrine are positive feedbacks. Okay? And then the last thing I wanted to show you, okay, and that's why I wanted you to grab your books, is that when you look at a couple things I want to point out. Page 491. Okay. On page 491, it has these breakdowns. Which ones are steroids, which ones are amino acids, and which ones are polypeptides. Okay? So letter A, cortisol. We already know what type of hormone is cortisol, steroid or non-steroid. It's steroid because it's composed of cholesterol. It's showing you that in that diagram. That's letter A. Then letter B, epinephrine and norepinephrine are really, really closely related in structure. And the other name you associate that with is adrenaline. But adrenaline is not a steroid. And when you look at that, the letter B on page 491, why can that not be a steroid? Because it's not composed of what? Like cortisol is. And aldosterone is. It's not composed of cholesterol. That's right. So then, when you look at letter C, parathyroid hormone, all of those little, let's say you see one like this, and then maybe, I think we said something like maybe glycine, and then we're going to say valine, and then phenylalanine. All of those little circles that are linked together are all separate what type of acids? Amino acids, okay? So then notice the last thing I wanted to point out was oxytocin, okay? What do you notice? What's the difference between the structure, besides the size of amino acids, besides the structure, what's the difference between parathyroid hormone and oxytocin? And you can read the little, for figure 13.4, it tells you the different categories for these hormones. We know cortisol, steroid hormone. Epinephrine, we know is what type of base? It's also amino acid, just like that of parathyroid hormone, but oxytocin is just a little different. What does it say oxytocin is? So for instance, it's got these two little S's in there. That is a what type of bond? What does it say for letter D? Okay. If you read the fine print. It's a peptide bond, okay? So therefore, we want to put a brown star next to oxytocin because that is a peptide hormone, okay? All right, so you've got vocabulary that you can look at. You've got this table, okay? And a lot of the information that you see here is also what you see here. And we've talked about the function of these hormones. The goal is not to feel overwhelmed. You might feel overwhelmed right now, but that's why today's Wednesday. We'll look at this a little more tomorrow and a little more on Friday. The only problem is, what does concern me is if you believe what the weatherman might say, if it's going to be raining all night and at some point changing to snow, is the ground temperature going to be warm enough to keep the roads from freezing? I don't know. Probably not. Well, having the wind blow might be a better chance of them not freezing. My point is, we could very well have a late start. There's no indication to say that, but don't be surprised if there's a late start tomorrow. Okay, so therefore, we've got this to look over as well. And again, a lot of that information is found on this table. We'll review this again tomorrow. Look over your vocabulary. That I still have that. We still have some people that need to make that up. So we'll get that taken care of. And then it's your time to ask questions about this. There are going to be multiple choice questions. Like for instance, what's the master gland in this system? Which one? Pituitary. How many portions of the pituitary are there? Okay. How many hormones are secreted by the posterior side? Okay. 2. But if we look up the table here, it's just 1. Okay. Then how many are secreted by the anterior side? Up here. Okay, well, anterior side. 1, 2, 3, 4, 5, and I think that's it. Okay? How many steroid hormones did we talk about? Well, I don't know. I think there's 4. 1, 2, 3, 4. Yep, there's 4 of those. Okay? All right. Is there anything that you'd like to add? Because we're about at getting close to 25 minutes. Okay, We'll catch up to you next time.